everybody. It's good to see you online again. Today I'm going to go over the atmosphere basics. So this is about the different layers of the atmosphere, what the atmosphere is made up of. Hopefully I give you enough information that you can formulate in your brains some answers to some questions that go with this assignment. So it's important that not only do you copy some of these answers into your notes so you can answer the questions, but you also pay attention to what I say. Again, not everything is directly in the notes. Some of it comes out of my mouth. So we're going to get going on this. So we have the atmosphere basics. Atmosphere composition. This is what we breathe, what it's comprised of, all the parts of it. But there's 4 specific parts that you will have to know. Of course, we need to know what the atmosphere is. It's a layer of gases surrounding a planet or other material body of sufficient mass that is held in place by the gravity of the body. That's a big fancy way of saying it's all the gas around an object that's big enough to hold the gas in place. One of the reasons why there's a big dispute over Pluto is some scientists don't believe that it has enough mass to have a gravity to hold gas in place. Others say it does. Same thing with Ceres, which is an asteroid in the asteroid belt, that they're debating whether or not it will be considered a planet. Again, it comes down to the ability to hold that gas in place. But that's what's required for it to be an atmosphere. So if we start talking about the atmosphere, it's a layer of gases. So there's different layers within the atmosphere. Each layer has its own little job. Each layer has certain key characteristics that you're going to have to know and understand. But when we take a breath of our atmosphere, in spite of what a lot of people believe, we are not breathing mostly oxygen. Oxygen, if you didn't know, is a flammable gas. What we're really breathing in is about 78% nitrogen. The bulk of what we inhale is nitrogen. There's about 21% oxygen. There's not quite 1% of argon, which is an inert gas that we don't really need to worry about, other than we know that it's in the first 4 components of what we breathe. And the last of the 4 main ingredients is carbon dioxide at 0.04%. Very little bit of carbon dioxide when we compare it to the rest of the atmosphere. But that carbon dioxide has a very huge role in us being alive on this planet. Now, when I said that oxygen is flammable, oxygen at 21% is a very special number. If we get up over 23 and 24% oxygen levels, the air itself could ignite. So high levels of oxygen really aren't good for living things, because that amount of oxygen can't ignite. Whenever you see people using a welding torch, they turn the gas on and they go click, click, click. A lot of that is acetylene. That's what's getting it going. But when they turn that knob and it goes from that big flame to the real tiny high heat blue flame, it's oxygen that's causing that. Whenever you see a house burning, the reason why that flame is big and continues to grow is not so much about the fuel that's burning, but the oxygen in the air around the fuel. So, that magic number of 21%, too low, we suffocate. Too high, we catch fire and blow up. So it's a real special number, and it plays a big role in us being on this planet. Alright, so that's what it's compromised of. And there's a cute little way you can think about what the atmosphere of our Earth is. think about the summertime when it's hot outside and you want to come inside to where it's nice and cool. You need something. You need that air conditioner, right? You got to have that AC. But let's say you don't have AC. You have no AC. So if you have no AC, then it's going to be really hot. So way we can remember nitrogen, oxygen, argon, carbon dioxide is the little acronym no AC. No AC means it's going to be too hot to live. And that's why those chemicals in the atmosphere are important. Now, when we start talking about the atmosphere and temperatures and stuff like that, we also have to think about the weather. Weather is the physical condition in the atmosphere at a specific place and time. So if I say, what's the weather like outside today? And you look out the window and you see a whole bunch of clouds, that moment in time in that place is what describes the weather. And it occurs in the atmosphere, specifically one particular part of the atmosphere that we're going to find out in just a little bit. Alright, so we're going to keep on moving. So we're going to start talking about the layers of the atmosphere. And we're going to do this as if we were out in space. We're aliens, and we're coming to visit the planet Earth. So we're going to start from way out in space and come slowly down into the Earth's atmosphere until we land. So as we're outer space, the first layer that we're going to experience, well, here's a nice pretty picture. I forgot that was there. So we can see the different altitudes. The exosphere is about a little more than 1,000 kilometers. It's way up there. Some of these pictures kind of give you an idea of what you might find in those particular layers, and we'll talk about those as we go. All right, so we're coming from space. We're aliens. We're visiting the planet Earth for the first time. And as our spaceship starts to enter the atmosphere, we're going to start getting into what's called the exosphere. This is the very top layer of the atmosphere. It's called the exosphere because exo means to exit. If we're leaving the Earth, that's the exit part of it. If we're leaving a classroom, that's the exit door. So that's the exit to the atmosphere. The end of the exosphere is the beginning of space as we know it. Some important things that you need to know about the exosphere. The temperatures are extremely cold. They get close to that absolute zero. Never make it in space, but as we leave the atmosphere, the temperatures are going to go down roughly about 3 or 4 degrees Kelvin, which is about negative 268, 269 degrees Celsius. The pressure becomes zero. There is zero air pressure in the exosphere. Some things that you might find as we're coming to Earth and we're starting to enter this is we're going to find the communication satellite. So every time you hook that little phone up to your head, hello, hello, you're sending a signal to the exosphere, and it's being relayed back down to Earth. So the satellites technically are not really in space because they're still within the realm of our atmosphere. The next thing we're going to notice as we're coming closer to Earth is the temperature is going to warm up very quickly. This is where things get a little weird. We get a lot of heat in the thermosphere. It is the warmest layer, and as you go up in altitude, that temperature increases drastically. You get up to over 800 degrees Fahrenheit, which is pretty high Celsius. Oops, didn't mean to do that. So it's a really bizarre area. The air in that layer is extremely thin. There's practically no air because we're nearing the exit. This is the heated air, and it's heated because of what's in the bottom part of this layer. So the solar radiation comes in through the exosphere, goes through the thermosphere, and part of it is reflected back up into space. So we're getting that temperature going two ways. So it's kind of like standing on a black parking lot. It's a lot hotter on that black parking lot than it is on the gray concrete because the sun is hitting and it's there. You got that heat um, doing its thing. Then, as we start to near the bottom of the thermosphere, we're going to get into a sublayer. It's not really a layer of its own, but it lives within the bottom of the thermosphere and the top of the mesosphere. And this is the ionosphere. Um, the ionosphere is an electrically charged area that kind of floats, and it gets bigger sometimes, it gets smaller, it sinks, it rises. So it's not necessarily a layer of its own, but it kind of hovers between the two layers of the thermosphere and the mesosphere. But what's important to know about this ionosphere is this is our number one first defense against the harmful radiation coming from space. Um, this also allows radio signals. The reason you can hear your radio in your car and listen to your jams, if you don't have a fancy thing where you can listen to your MP3s or phone, but the radio waves go up from Earth and hit the ionosphere and bounce back down to Earth. That allows us to watch TV. But it also, again, it bounces the harmful radiation back out into space, most of it. One of the effects that this has is called the aurora borealis. This is the northern lights. There's also a borealis in the Arctic. I'm not sure what the name of that is, but we're only concerned with the aurora because we live in the northern part. The aurora borealis or the northern lights are amazing. If you ever get a chance to go up north, like way north, and you can see these, they're amazing. So that's one of the key things about the ionosphere that you need to know. It's not its own layer. It's not really technically a layer. It just hovers and floats between two. Alright, as we're coming towards Earth, the next thing that we're going to hit is the mesosphere. Meso means middle, so this is the middle layer. Whenever you're out and you're sitting out at night and you're watching the stars and you see a bright light and a streak across the sky, you know you make your wish because you just saw a shooting star. Well, it's technically not a star. It's a rock that was in space, an asteroid, has entered our atmosphere, and it starts to burn. As it burns and becomes a meteor, in the atmosphere it's a meteor, and it starts to burn up. It's burning up in that mesosphere. It was superheated in the thermosphere, it hits the mesosphere, and the air is much denser. There's much more resistance. There's a lot more friction. So that's what's causing this rock to heat up and start to burn. So we can see the meteoroids when they're in the mesosphere. This is also a very cold layer. It gets down into the low negatives on this layer. So that's part of why it's a drastic change from the heated thermosphere. You go through the ionosphere and then it gets cold. So that hot rock starts to burn because it's cold. That means the air is much denser than what it was before. still very thin, but it's thick enough that it can burn up the meteoroids. Now we're going to continue going down. Other things you need to know about the mesosphere is that it is the coldest layer in our atmosphere. And that's because that heated radiation is being bounced off, so there's not much left to come through, so there's not much to warm that air up. And as we continue to go towards the Earth, the air pressure is increasing, so our altitude is going down, our air pressure is going up. So altitude is going down, air pressure is going up. As air pressure increases, that means there's more and more air molecules in the area. So we get through the mesosphere, and we're going to hit another sphere that is going to start to be where we see a lot of stuff happening. So our next layer is the stratosphere. The pressure at the top of this layer is 1,000 times less than what it is where you're sitting right now. So in the time, in the space from where you're sitting to the top of the stratosphere, there's 1,000 less units of pressure pushing down. As we go up in the stratosphere, temperature starts to increase. It gets a little warmer, not much. Whenever we have specialized weather balloons go up to take special readings, that's those huge silver balloons that you sometimes see in TV, or you may have actually seen one leaving the base. Those are weather balloons, and they will go up into the bottom parts of the atmosphere of the stratosphere. Now, strato means layered, and it's more important when we start talking about clouds. But it's a thin. It's still very thin atmosphere. There are only a few types of planes that can actually fly in the bottom part of the stratosphere because the air is so thin. Mostly they're military and supersonic planes. So they're going so fast that they don't have to have as much air to create lift to hold them in place. Again, it's very specialized. So we're in the bottom of the stratosphere, and we're starting to see a lot of clouds type buildup. And we start to enter another part that's not really a layer, but it's called a layer. And that is the ozone layer. And ozone is marked by O with the sub 3. That means it's the little 3 hanging at the bottom of the O. This layer varies in thickness. It's like the ionosphere. It kind of hovers, and it gets bigger, and it just kind of floats and does its own thing. And its reason it does that is because of the amount of oxygen that binds in O3, so 3 oxygens binding together. Also, the amount of carbon dioxide plays a role in the thickness of the ozone layer. So that's why it varies. Now, this is an extremely important layer. So we had the radiation come, it hits the ionosphere. Most of it's bounced back out into space, but there's some that comes through. Well, the ozone layer helps filter out the very harmful ultraviolet radiation. If we had no ozone layer, we would be dead because of the ultraviolet radiation. It would cook us. The ozone layer also helps regulate temperatures, keeps the temperatures on Earth relatively mild so that we can live. If we take a look at Earth's sister planet, Venus, Venus is the hottest planet in the solar system. And it's not because of how close it is to the sun, because Mercury is even closer, but Mercury is nowhere near the temperatures of Venus. Venus is the hottest planet on the sun because its atmosphere is primarily carbon dioxide, which is a greenhouse gas. All the radiation comes in, but it doesn't let it out. So it's constantly keeping that heat in. And it's the very bad radiation, like ultraviolet radiation, because there's very little O3. It's mostly carbon dioxide. Now I said carbon dioxide affects this layer. And the way it does that is carbon dioxide will break apart the O3, those ozones, break them apart so that the carbon can bind to the oxygens and form, so it thins it out and breaks it. It is believed that one of the ozone layer holes was caused by a lot of carbon dioxide in the atmosphere. Now again, this is not a layer in terms of the atmosphere layers that we need to know, but it's like it's a buffer. It's in between, and it's called an ozone layer just because it's a layer of ozone, not that it's its own atmosphere component. All right, so we started in the exosphere, very thin, very cold. We start coming down, and the temperature increases drastically through the thermosphere. We bump into the ionosphere, which is a radiation barrier. It's charged ions. We go through that into the mesosphere, which is the middle layer. Things start to cool off as we go through there because a lot of energy is being reflected back into space. As we continue to go down, the atmosphere is increasing and pressure is increasing. The amount of air is increasing. We hit the stratosphere, and we're starting to see a little bit of our weather and stuff, like clouds near the bottom. We hit the ozone layer, which protects us from those harmful ultraviolet radiation. And now we're entering into the most important layer of all, the troposphere. And the reason why it's the important layer is because, well, we're here. All living things on Earth live in the troposphere. It is the bottom layer of our atmosphere. All the landforms are found in the troposphere. All the weather occurs in the troposphere. The water cycle occurs in the troposphere. So it is the most important because everything going on in terms of the water cycle, the weather, life, it keeps us living is the troposphere. And of course we know that the air in the troposphere is mostly nitrogen, then oxygen, argon, and then carbon dioxide, because we have that no AC part. Now, tropo means to change, and it's called the troposphere because this layer of the atmosphere is in constant flux, and that constant flux is called the weather. Alright, so we finally made it to our Earth. So we're going to review the bottom layer, is called the troposphere, which means to change. The water cycle occurs in the troposphere. We're in the troposphere. Going up, we hit the stratosphere. This is where the ozone layer is. We start to warm up with altitude. Because of that ozone layer, there's extra energy where some of the violet radiation is being bounced back, some of it's let through. It creates a nice barrier between the cold above and the living below that needs that protection. We go through the stratosphere, we end up in the mesosphere. The middle layer things start to get cold. As we continue to increase our elevation and we're leaving the planet, we hit the thermosphere, which is drastically hot compared as you increase. It's a drastic change in temperature, and the reason it's that way is because the ionosphere in that buffer layer there that reflects a lot of the solar radiation. So that's why the thermosphere is so hot. And as we start to leave the thermosphere, the atmosphere becomes extremely thin. The air pressure is getting close to zero. temperature is getting close to 2 or 3 degrees Kelvin, which is very close to true zero. And then we, of course, leave the exosphere, which means we exit, and we go back into space. So here we have our pretty pictures again. As you can see, the troposphere, it's about 2,000 kilometers. It's a pretty good clip. And you start to see, well, you see all of the weather. This is where we see planes, aircraft fly in the troposphere. So if you're going to fly to, say, you have to go on a nice trip to Rome because you got it like that, you're going to fly in the troposphere. Now, if you're one of those crazy daredevils, you're going to jump out of the plane in the troposphere. Some of you may actually, in your life, decide you want to climb Mount Everest, and you're going to get to the top of Mount Everest, which is the tallest mountain on our planet, and you're still going to be in the troposphere. Some of you may join the Air Force or have a family member who's in the Air Force who's a pilot, and they fly the specialized supersonic fighter planes. They fly at the very bottom layer of the stratosphere. Some people who do a lot of weather reporting and research are going to use a weather balloon, and it's going to go into the mid-layer of the stratosphere. Of course, all weather occurs down here with us living people, the water cycle. And as we continue, you notice this is our temperatures. So our temperatures are going down as we go up until we hit the stratosphere, and it starts to warm up because of that ozone layer. Then it starts to get cold again, and then it's going to drastically increase. In fact, this graph would go all the way past off my chart and then come all the way back down off my chart in the other direction as we enter the exosphere. Spacecraft and satellites are in the exosphere. The International Space Station is in the bottom of the exosphere, top thermosphere. We start to see, we can see the northern lights or the aurora borealis because of the ionosphere. We see meteors burn up in the mesosphere, or in the bottom parts of the thermosphere. So a lot going on in our little ball of air around our Earth. You should have enough information to answer these questions. Keep in mind some of them have to do with life. So where does life occur? If something in the layers above is taken away, how will that affect us? Are some of these questions. Read the questions carefully, because some of them look like they're the same, but the wording is different. So you have to read them very carefully. Alright, I do believe that is the end of my slide presentation. That's the end of this lesson. Make sure you fill out your notes, get them turned in, and until then, I will see you online.